Okay, guys, good to see you. I think we have two new students. I think we have Javid, also Arad, Eldar, and one more, Nurgül. Okay, you just listen. Hello, Mr. Gaston. Nurgül, welcome.
Hello.
Nurgül, can you turn on your camera and introduce yourself? And after that, if you want, you can turn it off. I think it's your
Okay.
first time here.
My name is Nurgül Candarlı, and I'm gonna be learning with you from now on.
Good. So you are grade 9 student, right?
Yes.
So where are you studying? Which school?
From Bak Oxford School.
Baku Oxford School. I see. Arad, are you also from Baku Oxford School?
Yes.
I see. Also, how about you? Also. Okay. Nurgül, welcome to this team. Actually, maybe sometimes studying alone is good. Sometimes studying in a group is good. And here seeing more people, 3 4 5 students, maybe if you see other people, sometimes it gives a motivation. And because we are human beings, if there's a kind of competition, you just prepare for that and you try to be better than other people. uh, are we recording? Okay, good. So in this regard, actually, here being together, and sometimes even if you have a kind of like, actually we have a group in WhatsApp, and you can just share some experiences, or if you cannot solve a problem, you can just ask each other and sometimes discuss together. That's really good, actually, also for your future, because after all, now you are grade 9, next year you will be grade 10, and soon you will be a student at the university, right? So we have to learn how to get along with people, how to share, right, our thoughts and everything with our people, and learn something from other people if you don't know, or share something with other people if you know. It is something like this. Anyway, so now we are 4 5 students here. Nurgül, welcome. Last time we were
Thank you.
solving questions from here. These are some sample questions. Arad, after this time, maybe once in 2 weeks, 1 hour, I'm gonna spend time for solving SASMO questions, okay? Maybe we will start from the past, from 2013 and 2014, and I try to prepare some challenging questions that is SASMO type questions. We will just discuss together, get some idea, and also I may give you some assignment, okay?
Okay.
Good, because as I told you, we were going to study maybe a few weeks, and after that we will start practicing such more questions. All right, now let's continue then. uh Last time, let me just quickly finish that question, and after that I will move to another question. Okay. Okay, so last time you were talking about this question 6. Javid, did you try this question, or did you understand the solution? I shared the solution.
I looked at it and your solution.
Or anyway, even if you understood or not, let's do it once again, okay? That is one SASMO type question. Maybe actually it was asked in the past, in some year, I don't know. The diagram shows a square of length 6 centimeters and 2/4 circular arcs of radius 6 centimeters, right? Find the area of the shaded region, leaving your answer in terms of pi and thirds. Third means roots, right? Square root of something or cubic root of something, fourth root of something. So that is the actually, what is it? The shaded part. Here, the tricky part is to be able to see these two curves. Actually, it is a part of a circle, right? It's a part of a circle. So for the first actual circle starting from here, that is, it is center, not center, uh, for this, let's say if I just write here A, right? OAB, for that quadrant, O is the center. How about for OA, I should write here B, I think, and this one is C, right? And for OAC, that is one quadrant. COB, also it is another quadrant. So how do we find the area of the shaded region? To answer this question, you need to have some idea about trigonometry, right? Using sine rule to find the area of triangle. And also we need to know how to find the area of a sector. What is a sector? We know the sector is, Arad, what is a sector? Can you define a sector?
Not
This is a sector,
complete
right?
circle.
What is a sector?
Not complete circle.
Not complete circle. What does it mean? You know, sometimes you ask a question like to primary students, what is a circle? It's a round shape, right? Yeah, it's also a good description, but it's not the mathematical or geometric description. Anyway, it's not a round circle, but math, it is a part of circle which is bounded by two radii. That's the first one, as you see, the second one, and an arc, right? So here we have an arc and two radii. So this region is bounded by two radii and arc. That's called a sector, right? And how do you find the area of the circle? And also just using the area of the circle, right? Here, this arc or this sector is subtended by the angle theta, right? So what is the area of the sector? The area of the sector is 1/2 times theta times r squared. And here, theta is in radian, right? This is the area of this sector. Okay, now to find this, as you see here, the first thing is if I just join this point and O, let me just call this M, right? And what is OM? Okay, if I just join this OM and MC, as you see here, we have an equilateral triangle because OM, right? As you see here, from, if you look at this, from C to M, and look at the arc OB, right? It's the distance between the circumference and the center. So actually that means that this is equal to this, and also that's also equal to this. Why? And also OC is the radius of the quadrant OAC, right? And CM is the radius of the quadrant OMB, right? At the same time, OM is the radius of the quadrant OAC. That means that all the things are equal. What does it mean? It means it's a equilateral triangle. That means that all interior angles are 90, I mean, not 90, 60 degrees. So actually to find this area, as you see here, let me just name these parts. I mean, this smaller part, this small part, let me just call this, it is A, okay? Let me just call this A1. And also this way is symmetric. Also this area must be A1, okay? And this triangle, let me just call this A sub 2. Then what is the area of the shaded region? That's equal to A1 plus A1 plus A2, right? So now, how do you find this A1? So actually this A1 is equal to, just if you look at this OMC, right? The area of the sector minus A2, right? What is the area of the sector? If I just use this one, we know that this angle is equal to 60 degrees, which is equal to pi over 3, right? So that's equal to A1 is equal to 1/2 times pi over 3 times r squared. What is the radius? It is 6 squared, minus the area of the triangle. And what is the area of the triangle? That A2, that's equal to 1/2 times r, that is 6 times 6 times sine of pi over 3. Javi, did you get this part?
Yes.
Because directly we cannot find this. Even if I know that, still I need to know actually this small part. As you see here, we call this segment actually, that we have sector and segment. Segment is the region which is bounded by a chord and arc. So if I just calculate this, what is it? That's equal to 1/2 times pi over 3 times 36 minus this one is 3. 3 times 6 is 18. And sine of pi over 3. Sine of pi over 3 is sine of 60. That's equal to square root of 3 over 10, which is equal to, now this one is 6 pi. And actually this one is just the area of the triangle. That's equal to minus 9 square root of 3. Now, if I substitute there, then the area of the shaded region is equal to this A1 plus A1 is 2A1. That is 2 times we have just found here. That is 6 times pi minus 9 times square root of 3. And the plus A2. What is A2? It's just this one, right? We have already calculated the area of the triangle. That is plus 9 times square root of 3. Now, if you simplify this, 2 times 6 is 12. Here we have 12 pi and minus 2 times 9 and plus 9 times square root of 3. That's equal to minus 9 times square root of 3 units squared. Nurgül, did you understand this question and the solution?
Yes, I did.
Very good. Javed, any question?
No.
Arat, any objection?
No.
Okay,
Actually,
Arat. Yes.
if you just remember that CM and OM are equal to OC, then it become all of it is easy.
Yeah. Actually, seeing that one is not easy. And also, for example, and also you need to know, I mean, the area of this A1, right? This small, this segment. And also, actually, this one is not so easy. Of course, once you understand, everything is easy. If you cannot see, everything is difficult.
Is it like the problem of that leaf in a square, which is like quarter of a circle minus that triangle? It's so similar to that.
Yeah, maybe. What question are you talking about? Say again.
Like, do you know the leaf in there's some like circle kind leaf in a square? Should I draw with annonate?
Yeah.
1 second.
Okay, 1. Okay.
This one.
Ah, okay. Yeah, it is something like this. Yeah, because also it is, right? You're talking about something like this. And this is the center of the circle, and you're just drawing an arc, right? At the same time, that is just take it as a center of another circle. Let's say this O1, and this one is O2. And you're drawing another circle here, right? And then you need to find the area of the shaded region. To find this one, we should again divide into 2. It is symmetric, right? Just find one part. And how can we find one part? Actually, that is the area of the sector minus the area of, I mean, half of the area of the square, right?
Okay.
And after
There
that,
is
you will
one
get
area
this.
as well.
Yeah. And also here, you'll get similar idea.
That leaf is always 57% of square area. Like when I did the so this one, every time you should draw the area of that square is, if you make it 57%, is that leaf.
Okay, very good. And how about this in this question? I don't think it actually fits into any formula. Okay, good. Arad, actually, in general, in math, if you can get the formula and if you derive a formula, that's a good thing. But just memorizing and relying on your memorization or memory, that's not a good thing. Okay, and we should know that we can get the formula. But here, okay, if you know this before the exam, if you know that, actually you can save time. But we should not just memorize the formula. If you drive yourself and understand this and you know the formula, it's good. But after all, you know, we have a lot of formula. You may forget this, but if you know the idea, using idea anytime, even like 10 years or 20 years later, you can actually drive this or solve the questions. And that's why by learning math, we are not memorizing something. We are just learning how to think, how to approach the problems, what kind of method we should use. And we are just shaping our thinking skill. Okay. Good.
Okay.
Let's move to another question. Let's move to the first question. I mean, you already solved this, right? Should we try this again?
No.
Okay. How about question 2?
Yes, because I have different answer.
You have different answer. What's your answer?
2014 divided by 3.
Okay. Here, the Fibonacci numbers. Fibonacci, you know, that's one of the great mathematician, Italian mathematician. And he's the one actually not discovered, maybe the first time officially published a paper about this sequence of numbers, right? And how do we obtain this number? It is 1 starting with first 1 and 1. It means that we are just starting this number sequence with 2 ones, 1 1. And after that, the rule is to get the next term, we have to add the preceding 2 terms, right? It's 1 plus 1, we get 2. 1 plus 2, we get 3. 2 plus 3, we get 5. In general, we know that, anyway, we can just write this u and blah, 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 general term. But here, where each term after the second term is obtained by adding the previous 2 terms. Okay, we know this. Now, how many of the first 2014 Fibonacci numbers are odd, right? How many? And to get this one, actually, we need to know the pattern. I don't know how to solve this, but let's see. Here we have 1, and let me.
In every tree, there is 1 even and 2 odd. If you look,
Okay,
because
sorry.
like even odd plus odd is even plus odd is odd.
Okay, and here we have, let's say, U 2014, right? So that's our first term, second term, third term. So how many numbers are odds? Okay, the first 2 are odds, all right. And after that, here we have 2, 3. Okay, this is odd, and this 3 is odd, 5 is odd. And here we have 13 is odd, 21 is odd, and 34, and blah, blah, blah. So that means that 1 even 2 odd, 1 even 2 odd. Is it like this?
Yes. Because when odd plus even is odd, odd plus odd is even.
Okay. All right.
So in every tree, there is 2 odd. So we multiply 2014 by 2 over 3.
2014 by 2 over 3.
Yes. Because if it be even, it should be divided by 3. But if it be odd, first multiply by 2, then divide by 3.
Okay. How about if we just first see here? Okay, we have something like this, right? It is odd, odd, even, odd, odd, even, and odd, odd, even, right? So that means that here, if I just pick this 3 and this 3 and this 3, right? And out of these 3 terms, 2 of them are odds, right? Is that right?
Yes.
Okay. So here 2014, we know that the 3 is not divisible by 3, but 2014, actually, I can write it as 2013 plus 1. Now 2013 is divisible by 3, right? So now out here, out of this 2013, right, how many the thing, actually, let me just write here, 2013 is equal to 3 times, it is 621, it is 7 1. So here we have 671, I mean, these triple groups, right? Or 3 tuples, let's say. In each group we have here. And among this, 2 of them are odd. So how many odd we have in the first 2013 terms? So here we have 671 times 2, right? Which is equal to, it is 2, 14, we have 1, 2 times 6, it is 13. 1,342, right? So
43.
how about the 14? It becomes odd, odd, even, odd, odd, even, and after 2014 will be odd. So it is 1, 3, 4, 2 plus 1. there must be 1, 3, 4, 3 odd numbers.
Yes.
Is that the correct answer?
Can you check it? Because the last time I checked it was
1,
something-
3, 4, 3. Yes, 1, 3, 4, 3. Okay.
Okay.
All right. Here the tricky point here is here actually you should just pick either 2014 or the biggest integer that is smaller than 2014 that is divisible by 3. Because here if you just make a group of 3, right? And how many groups do we have here? And in each group we have 2 odd numbers, and after that we know the pattern here, OOE. After E actually just continue here, 2014 will be O. So we need to add one more thing. Okay, good. Next question 3. We already did this. And how about question 4?
Can we do?
Okay. I'm thinking about the general solution, but general solution involves some function and polynomials. I haven't reached the conclusion yet, okay? If I do, I will just show this. But here, I'll just show you different method, very fast method, especially if you're sitting in the exam, for example. Assume that you are sitting in the Sasmo Hall in Singapore. Today is, what is it, May 7, let's say, and you don't have much time, right? The time is limited. So what is the fastest way, especially that multiple choice questions or this kind of questions? How would you solve this question? Anyway, let's say in the exam you have this question. Find the smallest whole number that leaves a remainder of 1 when divided by 3, a remainder of 2 when divided by 5, and a remainder of 3 when divided by 7. Okay, and we know that just simply if we divide 13 by, let's say, 5, for example, how many 5 do we have in 13? We have 2. 2 times 5 is 10, and here we have 3, right? So I can write this 13 as 13 is equal to 5 times 2 plus 3. And in math, we call this 13 is a dividend, right? And how about this 5? 5 is the dividing the number. We call this a divisor. And how about this 2? 2 is the result. We call this quotient. Quotient. And how about this 3? We call this 3 a remainder, right? In general, if I divide any number, m, for example, let's say we are talking about the smallest number. Let's say that number is m. So that m is equal to, if you divide it by 3, if I divide this by 3, let's say our quotient is a, and the remainder is 1. And again, the same number, m, if you divide this by 5, is it 5? Yes. Let's say the quotient is, I don't know what is it. It is b, and the remainder is 2, right? Now, if you divide the same number, we are talking about the same number here. Let's say we divide this m by 7, and also we have quotient because we actually get something right here. That is c, let's say, and here the remainder is 3. Okay, I don't know indeed this stuff. Okay. So now we need to find, if it is so, what is the smallest number? M minimum. We know that M minimum is the whole number. What is that number? That satisfies all of these conditions. And of course, we may have infinitely many numbers. We are just looking for the smallest one. One approach here is actually, here, the biggest divisor is 7, right? If I just take the last one, for example, and what are the whole numbers? When you divide by 7, the remainder is 3, okay? And actually it is not 3, it's too small. If I just start with 10, for example, the first number will be 10. The second number will be 17, and it is 24. It is 31, 38, 45, 52. Okay, I can just write maybe 5 or 6, okay? Among these numbers, which one is the one that satisfies these also 2 conditions, okay? For example, 10, if you divide by 3, remainder is 1, okay, but it's divisible by 5, right? So actually when we divide by 5, remainder must be 2. So actually this 10 I just cross out, and also this 45 divisible by 45 cross out. And also the numbers which are divisible by 3, because when we divide by 3, remainder must be 1.
24.
Also here this 24 actually just all right, cross out, right? And after that, how about 17? If I divide 17 by 5, remainder is 2. But if you divide by 3, remainder is 2 again. So this cannot be the answer. 31 also, if you divide by 5, remainder is 1. But here remainder should be 2. Also, it doesn't satisfy the second condition. If you divide 38 by 3, for example, remainder is 2. It does not. But how about 52? If you divide by 3, the remainder is 1. So 52 is equal to 3 times 17 plus 1. And if you divide 52 by, for example, 5, it is 5 times 10 plus 2. And if you divide this by 7, it is 7 plus 3. So the smallest number that satisfies all of these conditions is 52. That is the fastest way to answer this question. Okay.
Teacher, but what if the number is so big?
Okay, very good question. Usually they don't ask such very big number. All right. If it is so big, at that time we need to use polynomial, but now I'm working on this. Okay. Let me just get the conclusion. All right. After that, I will let you know. But now I have to test my results. All right. Because to answer this by polynomial, and you need to know some remainder and factor theorem about polynomials. But actually it's for a function. And also if our input values are discrete numbers, at that time also it should work. But now I'm working on it. I just started. Let me get the conclusion and I will let you know about this general solution, okay?
Okay.
About question 5. Javid, did you try any of these questions? Javid,
Yes, I'm sure.
did you have time to solve any of these questions?
No, I didn't.
Eldar, how about you?
Yes, I'm watching everything.
Eldar, did you try, for example, question 5? Did you solve it or could you solve it?
Yeah, the answer will be 0.
0?
Yeah.
No. Nurgül, how about you?
But Mr. Kasim, I don't know where these papers are.
Miss
No,
Elena,
actually, Nurgül, can you see the question 5? Let's say now you have to solve this question. Do you have any idea how would you solve this question? Just tell me one idea. Just give me an idea.
If it were me, I would just solve them by just multiplying them, if it were me.
But these numbers are so big. How do you multiply them?
Even if it takes a little time, I would just solve it by multiplying because it takes the least time for me to multiply them.
You are talking about 8-digit numbers. Okay. Arat, how about you? How did you solve this question?
I would first factor out something like taking them, make them the same, then the numbers are left, then we minus them.
Okay,
Actually,
guys, usually the main idea is in this kind of questions in Olympiads and competitions or exams, okay, we need to actually utilize the algebra. And we know that actually what is algebra? Algebra is a tool, right? For example, if you just open this file, for example, here, if you see this PDF, right, Acrobats, you see some tools at the top, right? For example, we have minus and plus and refresh and draw, highlight, erase. These are the tools, right? If I just click plus, for example, it just enhances the screen or it just zoom in the screen, right? And also, for example, if you open Excel, we have a lot of tools, right? Using tools, you can actually do or carry out some kind of task easily. And also algebra, this kind of tool in math. Using algebra, actually, we can solve problems, right? Algebra's main job is actually how to say, is a kind of tool so that it helps us to solve the problems easily. And without algebra, even very simple problems are very, very complicated, especially if the result, I mean, the solutions are not whole numbers or something. It's really hard. Okay, let me just check chat box. Can I find these exercises online? Nurgül, of course you can find this. Okay, these are SASMO sample questions. If you just say SASMO sample questions, let's say grade 1, grade 2, grade 11, you can just find this. And also I have all of this. I can just share with you. These are just from the internet, okay? And also I will share you some more questions a little bit later. Okay, let's just study 2 more chapters, and after that we will start solving past papers, okay, starting from 2013, and hopefully we will start those questions together.
Okay, thank you.
Okay. All right, good. Now this one, Google just write SASMO sample questions, you will get this exactly the same file because it was just displayed by SASMO. And good, guys, let's continue. So how do we use algebra? Here we have 2014, 2015, and 2014, 2014, right? Let's say this 2014, 2014, that is X, for example. Then how about this number in terms of X? This will be X plus 1. And let's say this 2015 and 2014, that is Y. And this 2015 and 2015, this will be Y plus 1. Now what we have here? Y times X plus 1 minus X times Y plus 1, which is equal to, now let's just expand this and simplify, XY plus Y minus XY minus X, which is equal to just Y minus X. Now what is Y? 2015, 2014, right? It is 2015, 2014. And how about X? X is 2014 and 2014. And if you subtract this, all digits are the same, except only this 10,000th digit, right? So that's equal to 5 minus 4 is 1, 0, 0, 0, 0. So the answer is 10,000. Usually these kind of big numbers, you should use this method. First, you have to simplify this, and after that, you can just substitute the values of this X and Y and evaluate your answer. All right, that's it. Let's continue. We did question 6. Nurgül, I will share immediately with you, or again, if you cannot find, just let me know. And also with the 7 and the 9. Okay, and 9 and 10. All right. How about question 9? Given that n factorial, right? We know there is a kind of notation in math. And why do we have to use this notation? And also in the future, you will see that in a lot of calculation, we have to actually, we have this kind of product, the product of maybe natural numbers, the product of maybe, what is it? Even numbers, the product of, for example, odd numbers, something like this, a lot. Even at university level, you will use this. And it's a kind of, what is it? Factorial means just compact notation of this long product. That's it. And after that, of course, we need to learn some properties. It says that n factorial is defined like this: the product of the first n natural numbers. Find the last digit of this number, right? It is 1 factorial plus 2 factorial plus 3 factorial plus blah, 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 blah. Okay. And guys, do you have any idea, Javid, Nurgül, Arad, Eldar, also, how do we solve this question? If you already solved it, have idea, just let me know. And after that, we will continue. How do we find this?
Because first, as it said, the last digit is means we should take the last digit as well, like 2014, we should just take the 4. And we should find the pattern of 1 till 9, the squares. It means 1 plus 4 plus 9. Then we will find the pattern. Then, yes.
No, actually, Arad, here the last digit means, for example, if I
Actually,
ask you just one number, let's say 1 factorial plus 2 factorial, right, plus 3 factorial, right? So if you just add this, what is 1 factorial? It's 1. 2 factorial, 1 times 2, it is 2. 3 factorial, 1 times 2 times 3, that is 6. So that's equal to 9. The last digit is 9, right? Here, the tricky point is, if I just write this here, 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial. Let me also just write this, and let me write 7 factorial dot dot plus 2014 factorial, right? Just after 5, actually, if you just look at this, what is 5 factorial? It is 1 times 2 times 3 times 4 times 5, right? Actually, what is it? It's just equal to, what I mean here is, in this factorial, we have two numbers whose product is equal to 10, right? What are these numbers? 5 and 4, for example, or 5 and 2. So that means that the last digit of this 5 factorial is 0. And how about 6? Also 6 has two numbers, right, whose product is 10. Like, for example, 5 and 2 again. That's also the last digit is 2. And actually, after 6, all of these factorials, the last digit is 0. Why? Because actually in this factorial, we have two numbers whose product is 2, right? That means that the last digit will be 0. So here, then I have to just calculate this one. 1 factorial, it is 1, 2 factorial, 2, 3 factorial, 6, 4 factorial, 4 times 6, that's equal to 24, which is equal to 33. So dot, 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 the last digit of this one is, what is it? 3. Because here we have something like this, 33, and dot, 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 the second one, for example, we have 0, and also here we have 0, dot, 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 until 2014, also the last one is 0. If you just add them all together, still the last digit will be this. Okay?
Okay.
All right. Okay, I have another question here immediately similar to this. After that, we'll try question 10. Okay, guys, it's for everybody. I'll give you maybe 3 minutes. What is the remainder? The question is, you should find the remainder. What is the remainder? If when we divide this sum, 1 cube plus 2 cube plus 3 cube plus dot, dot, dot plus 99 cube, okay? What is the remainder of this s when we divide by 4? Okay, actually, you're just dividing this s by 4. We have here quotient, right, and the remainder. The question is, what is the remainder?
It's not impossible.
But did you understand the question? Javid, did you understand the
Yes,
question?
but first we have to find this.
Okay, Ara, think you have 3 minutes. Let's discuss this after 3 minutes, okay? At least think first. Okay, 3 minutes, time starts now.
Teacher, I found
Okay, what is the answer?
0.
0. Very good. Javid, any idea? No. Nurgül, how about you?
At first, I thought it would be 0, but then if you substitute for the x, then it can't be 0, can it? So I did it different and I got 21 as the answer.
21.
Yeah.
What do you mean 21? If you divide the
Remainder
number
cannot
by
be.
4, the remainder should be either 0 or 1 or 2, right? 0, 1, 2, or 3.
I don't know. I just got 21 for this one. First, I thought like it would be 0, but then I thought maybe it wouldn't be 0 in this exercise.
Okay. Okay, Eldar, how about you? Do you have any answer?
No.
Also, how about you? Okay. Arat, just tell me the idea. How did you get it?
Firstly, every even number being cubed is divisible by 4. So all of the evens are gone. And when you add two odd, two odd, you will get a remainder of 2 when you add their cubed. And because it's, as you continue, you will get 0. The last pair, because it's 99, you will get the 7 squared, 98 squared, and 99 squared. Because 98 is even, so that one is crossed. And to find if the number is divisible by 4 or not, you have to look at the last 2 digits. So we will take 7 cubed and 9 cubed. We add them, the last 2 digits will be 72. 72 has no remainder in 4.
Okay. All right, that's also fine. But here, guys, I'm going to show you different method. Okay, that's more mathematical. Before I start about solving this question, now you got the question. Let me just delete them because I need some space. All right. Let's change the color now. Use brown. We know that's a cubed plus b cubed, right? You know how to factorize this. That's equal to a plus b. And here we have a squared minus ab plus b squared. Is that right?
Yes.
Yes.
Okay, so this one, actually the second part, I don't need this, but I know that that's also kind of whole number, right? Let me just denote this by, let's say, a, for example. Then I can just write it as a plus b times a. That means that's a cubed plus b cubed. If this a and b are whole numbers, they are always divisible by a plus b. This shows this, right? Is that right? So from here, let me just rewrite this as, in this way. Here, I will just take the first and the last and write them together. Here we have 1 cubed plus 99 cubed. And now I take the second one and the one before the last one. So that is 2 cubed plus 88 cubed. And here we have 3 cubed plus 87, not 87, I think. It's 98, right? 98. And that is 97 cubed. Dot, 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 it continues. And we have only one number here that doesn't have pair. What number is it? That is 50, right? 50 cubed. Now, according to this, as you see here, right? And the first one, I can write it 1 plus 99. That is 100. Let's say A1. And the second one, 2 plus 98, it is 100. And the remaining one, let's say this A2. Dot, dot. And how many we have here? It is 50, right? Here we have 100 times A49. And here we have 50 cubed. 50 cubed is 2 times 25 cubed. As you see here, all of these numbers are divisible by 4, right? Now from here, I can just take this 4 outside the bracket, 25A1 dot dot, and here we have 25A49, and plus here we have 2 times 25 cubed, which means that this number is divisible by 4, and the remainder will be equal to 0. Okay, that is the proving way, actually exactly how you verify your answer. Now, they may add, for example, one more term, dot, dot. How about if they add 100 cube plus 101 cube? We can just take until 99, and this one is already divisible by 4, and just how about 101? So here we have only 101, and also we can write 101, for example, cube as 100 plus 1 cube, right? And I can just write it as 100 times a plus 1 actually, because all, if you expand this, all the terms will have 100 except only the last one. So that means that if you divide by 4, the remainder will be 1. Okay. All right, guys, now let's get back to this question. How about question 10? Nurgül, how would you solve question 10?
Do you mean the question you're on right now?
Yeah, here, this one. This one. It says, let x be a number such that x plus 1 over x equals 5. Find the value of x to the power of 4 plus 1 over x to the power of 4. Okay, guys, you might solve this. Okay, let me just solve again. If you solve this in the same method, it's good. If not, you learn something here. What is given here in question 10 is given that x plus 1 over x is equal to 5. So we need to find here x to the power 4 plus 1 over x to the power 4. What is it? To do this one, first, if you square both sides, for example, if I just square both sides, right? What do we got here? Here we have x squared plus 2 times x times 1 over x plus 1 over x squared. On the right hand side, we have 25. As you see here, this x and 1 over x, these are the reciprocals of each other. Reciprocal means multiplicative inverse, right? So that's equal to 1. And after that, since the whole thing is 2, take to the right hand side, then here we have x squared plus 1 over x squared is equal to 25 minus 2, that's equal to 23. Now, once again, if you just square both sides, what we have here? We have x to the power 4 plus 2 times x squared times 1 over x squared plus 1 over x to the power 4. On the right hand side, 23 squared. 23 squared is 529. Now again, here we have 2, take to the right hand side, dot, 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 x to the power of 4 plus 1 over x to the power of 4 is equal to 529.
527.
Huh? 527.
We take
Because
that plus
529 minus 2 is 527. Okay.
okay. Actually, I think this was the easiest question.
Yeah, that's easy, Arad. These are just to give you some idea. Okay, these are simple questions. But how about if I ask you, for example, not x to the power 4, x to the power of 12, for example? At this time, actually, it's a bit long, but if you get the idea, just you need to do the questions fast. Okay. In math, actually, just knowing is not enough. We should be very careful with this. You may know, you may know this, you may know the technique, but how actually you can increase your speed? Only way to increase your speed is we have to practice. As you practice more and more, you get more self-confidence and you have more intuition about the concepts. When you look at the problem, ideas, do they come quickly or you have to wait for like 2-3 minutes? It depends on how much you are putting effort into this, how much time you are spending on solving problems, how much do you love, actually enjoy solving problems. It's not only solving, once again, we are shaping our problem solving skill. We are shaping our thinking skill. Now, really guys, now study hard for like maybe 5-6 months. You will see that it will actually, you will see, I mean, how to say, you will benefit from this your whole entire life. Even when you go to a college, when you go to a university, when you were listening to lectures from, let's say, professors of the best universities, when they talk, you can understand so quickly. That is the most important thing. Okay, guys, I have to finish this. Nurgul, let me just write my number quickly, or maybe you can just contact Mr. Adalat. If you just say hi, we will add you to our WhatsApp group, 855-959-82881. That is my WhatsApp number. Hi, Mr. Qasim, I'm Nurgul, grade 9. If you just say like this, I will add you to this WhatsApp group. And we will communicate each other through that group, okay? Anytime if you need some questions for solving, if you feel bored, just let me know. I will send you questions for practicing. Okay, guys. Thank you very much. I will see you on Friday. Okay, Friday we will start new chapter. It's about applications of mathematics in practical situations, and we will see some business problems there. Okay.
Okay. Have a nice
Just
day.
can I stay to ask a question?
But how do you create your own problems out of questions faster? Formula. Okay, Nurgul, just keep this. Okay, I will ask this question later. Arat, now I have class. Other students are waiting. Okay. Later, Arad, actually, other time, if you just let me
Can
know,
I
Mr.
send it?
Qasim, can we have discussion? We can meet one-to-one and discuss like 10 or 15 minutes, okay? Now I have to close this because I need to start another class
Um,
after 4 minutes. Yes, Arad.
Yeah, okay.
Okay?
And no, I just said okay. Okay.
All right. After 1 hour, I will be free. If you have time, you just let me know, okay? We can meet again. I mean, if you have questions, we can have some short discussions. Okay. Guys, I will see you on Friday. Thank you very much. Maybe I will send you some questions for practicing, okay? Bye-bye.
Goodbye.
Bye.
Bye. Thank you.